Okay, so we're going to go through a few exponential word problems just to practice for the test that's going to be coming up on this. And so in this first one, we have $2,000 in a bank account. And so the first thing we'll do right off the bat is just recognize that if we have $2,000 in the account, that's the initial amount. That's how much we're starting with. Okay? And that's going to be our B value when we write our exponential equation. Our account earns 3.4% interest. Now, that it's earning means it's going up, right? And it's going up by 3.4% every year. And so that's what clues us in to know that this is exponential. Anytime you see increase or decrease by a percent, that's always an exponential equation. So in order to find our common ratio between how much we have each year, we need to take 100% of what we have and add to that the 3.4%. Because we don't lose the money that we start with. We keep that 100% that we started with, and then we add 3.4. So 100 plus 3.4 would be 103.4%. And then in order to turn that into a decimal that we need for our equation, we have to think about what percent means. Well, percent, right, means per means divided by, and cent means 100. So 103.4% just means 103.4 divided by 100. Now, if you need to, you can use the calculator for that. Right, so I've got the calculator here. We've got 103.4 divided by 100. But you can see that all that happened was the decimal moved over by 2 places. And anytime you divide by 100, that's what's going to happen. So all we have to really do is just move that decimal over 2 places to the left. Okay? So 1.034 is going to be our R value. And this will be the same every time. Okay? So then when it says in the next sentence, to write an equation to represent the amount of money in the account after X years, well, we just need to remember that our explicit equation for an exponential function is f of x, or y, we'll use y this time. Y is equal to our initial amount, our y-intercept, b, times r to the power of x. Right? So this is b times r to the power of x. And that's what we're using. So if we want to know how much money is in the account at the end of 11 years, then all we have to do is replace our x with 11. And for this, again, we'll go back to our calculator. We're just going to do 2,000, and you can put it in parentheses, just like I did. And then parenthesis 1.034 to the power of, and that's this button right above the division sign. And on your calculator, it may not actually make it look like an exponent. It may just put that little up arrow. And then you can put the 11th power after that. I'm going to close my parenthesis. And we can see that we get 2,889.055747. So we'll go back over here. This is 2,889.055747. Since we're dealing with money here, we're always going to want to round to the nearest cent. Cents would be 2 places after the decimal. So we have to look at the term after the second decimal. If it's 5 or greater, then we'll round up. So this is 5 or greater because it's a 5, which means we're going to round this up to $2,889.06. If that had been a 4 or less, we would have kept it at 5 cents. So that's our first example. we're going to do another example that's going to be almost exactly the same. In fact, I even happen to start with $2,000 again. So if we read this, we have $2,000 in a bank account. That means our B value will be 2,000. We're earning 1.34% interest. Okay. So this time we have 100% plus our 1.34% gives us 101.34%. To figure out what our R value is, we just need to take that decimal and move it over 2 spots. So our R value is going to be 1.0134. Using our form, y equals b times r to the power of x, our equation to represent the amount of money in the account after x years should be y equals 2,000 times 1.0134 to the power of x. So now we have to be careful here about what our value of x is. It says how much money is in the account after 3 years, but we're earning this interest every month. So we need to take into account that 3 years is equal to 36 months because, well, there are 12 months in a year. So 3 years is going to be 36 months. So to find our value, we've got y equals 2,000 times 1.0134 to the power of 36. And so once again, we will just put that into our calculator, figure that out. We'll put our 2,000 into parentheses. We'll put our 1.0134 to the power of 36. And we will get 3,229.552836. So 3,229.552836. And if we're going to round this to the nearest cent, we'll look at this third place. It's less than 5, so we do not round up. We'll just keep it as it is. We have $3,229.55. All right, for our next one here, we have a new car that's value decreases by 11% after every year after it's been purchased. We originally paid $28,000 for the car, so we should be clued in right away that the original value, our B, is going to be $28,000. We want to know how much is it worth after 7 years, and we want to write an equation for how much it's worth after any number of years. So we're going to see that our car is decreasing by 11%. That decrease by a percent is telling us this is exponential. We start with 100% of the value, and then we subtract 11%. Well, 100 minus 11 is 89%. So in order to turn that into a decimal, we'll move the decimal point over. The decimal point would be right here. We'll move that decimal point over 2 spots. So R is going to be 0.89. And then again, we'll just use our same formula. Y equals B times R to the power of X, which gives us 28,000, because that's our B value. R of 0.89 to the power of X. If we want to know how much it's worth after 7 years, we'll just put in 7 for our x. So if we go ahead and put this into our calculator, we'll put in parentheses 28,000. And then in our second parentheses, we have 0.89 to the power of 7. And we end up with 12,384.77377. It's not 12,384.77377. Again, we'll look at the third number here to round to the nearest cent. Since that's less than 5, we won't do anything. We'll just keep it as 0.77. So our final answer should be $12,384.77. All right, we'll just do one more here. We have a stock that's value is decreasing by 2.5% each day. Okay, so it's decreasing by 1%, which tells us that it's exponential. Our initial value is $700, so that's going to be our B value. And we want an equation to represent the value at the end of X number of days. And then we want to know how much it's worth after 2 weeks. So we start with 100% of the value, but every day we subtract 2.5%. Well, 100 minus 2.5 is 97.5. So every day it's 97.5% of what it was worth. Then we'll take the percent and move the decimal over 2, because that's how we divide by 100, to get an R value of 0.975. So now we've got both things that we need to write our equation. Once again, our equation's form is y equals b times r to the power of x. And so we'll put in 700 for b and 0.975 for our value for r. We want to know how much this is worth after 2 weeks. Well, if it's decreasing by this amount each day, 2 weeks should be 14 days, because there are 7 days in the week. So we're going to replace our x with 14. And we'll just put that into our calculator again. So this time we've got 700. Stock was worth $700 to begin with, and it decreased by 2.5%, so that's 0.975. And after 14 days or 2 weeks, we should see that it is only worth $491 and some change. So not a great investment for us here. So this ends up being $491.091773. And again, we'll look at our third decimal to round to the nearest cent. Since that's less than 5, we will just leave this as $491.09. And so that's a walkthrough of kind of the different types of exponential word problems we might see coming up on the test. Now it's going to be time to practice a bunch of them on your own.